Bismillah ar-Rahman ar-Rahim. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. Today's lesson is on A-level maths, pure maths year 2, and we're looking at R cos x plus alpha. If you're following through in the book, it's chapter 7 of the Edexcel Pearson book, and we're looking at example 15. Bismillah ar-Rahman ar-Rahim. Just a quick reminder of what we're trying to do here is we learned the a plus b formula for cos. So cos of a plus b, two angles added together, can be written as cos a cos b minus sine a sine b. So what we're trying to do today is we're trying to do it in reverse. So we're trying to take the right hand side is given to us, and we're trying to figure out what was the original question, what was the original part on the left. And we're using that because it's much easier to then go and solve the equation using the left-hand side. The left-hand side is much shorter, much simpler than the right-hand side. Okay, let's take a look at the example. It's example 15 from the Edexcel Pearson book. Express sine x minus root 3 cos x. Express sine x minus root 3 cos x in the form I think we've done that one already. Let me go to the right example. So this is example 16. Express 2 cos theta plus 5 sine theta in the form r cos theta minus alpha. R cos theta minus alpha, and the conditions are r has to be bigger than 0 and alpha has to be between 0 and 90. Okay, because we're told in the question that the form is r cos theta, is r cos, not r sine, but r cos theta minus alpha. That's what we're going to start with. We're going to take this r cos theta minus alpha and we're going to expand it out, or we're going to rewrite it in the other form. So we can put r at the beginning of everything. R is just at the beginning multiplying out everything at the end. So we can put r in at the front. Let me do it the other way. Let me take that equal sign and put it underneath just so you can follow what's going on a bit easier. So let's put that down here. So we can keep r as it is. That's on the outside of the brackets. But we want to really think about the identity that you learned for cos of a double angle. So how does that go? That's going to go like cos theta, cos alpha, with a's and b's, it's cos a, cos b minus sine a, sine b. We saw that a second ago. So let's try that here with the theta and the alpha. It would be cos theta, cos alpha minus sine theta, sine alpha. So I'll put in a couple of blanks there. Let me fill them in now. Cos theta, cos alpha minus sine theta, sine alpha. Once you got that identity right, then you just want to multiply out the r at the beginning. So we'd have r at the beginning here. So r cos theta, cos alpha, and we'd have an r just here before the sine. So let's put that in as well. And the goal is to try and figure out what the alpha is and what the r is. So now we've multiplied out the r, we can get rid of the brackets and put that in here. So how are we going to figure out what r is and what alpha is? Easy, we're just going to compare it to what we were told at the beginning of the question, that it's really 2 cos theta plus 5 sine theta. So if that's how it ends up, then you've just got to compare like with like. So what looks like each other? You got the cos theta here, looks like the cos theta here. So what's left in that first term? Oh, I think I made one mistake. With the cos, the sign changes. So we've got if you got minus in the middle here, then when you do the expanded form, that's going to change into a plus. Okay, that's better. So let's compare like for like. We got this cos theta in the first term is very similar to this, is exactly the same as this cos theta. So what's left? This 2 is left, and on the one on the top, there's a lot more than just one thing. It's the r and the cos alpha, which is left. So making that comparison, what we can say is that the r combined with the cos alpha, so r cos alpha, has to be equal to the 2. Remember what we're saying is that in the line in blue is the same as the line in black. Or said express it in the form r cos theta minus alpha. It means it's the same thing, but just expressed in a different way. Just like 2 plus 1 is really 3, but it's just expressed in a different way. So the line in blue can only be the same as the line in black if the 2 matches the r times the cos alpha. So that's the first equation we can write. We can say this r times this cos alpha, those two together have to be equal to the 2. So this 2 has to be equal to the r cos alpha. So that's your first equation. And then we can do a similar matching type thing on the second term. So we've got sine theta here matches the sine theta here. So what's left? You've got the 5, and you've got in the line in blue, what's left is the r and the sine alpha. So that's our second equation. The r sine alpha has to be equal to the 5. R sine alpha has to be equal to 5. Have we figured out what r is yet? Have we figured out what alpha is yet? No, but we are very, very close. First thing we're going to do is just put this equation underneath. So I've got the sine one on top and the cos one underneath. Then I'm going to take advantage of sine divided by cos is tan. So if I divide everything on the left by everything on the left, then everything on the right gets divided by everything on the right. So I'll end up with one new equation. On the right hand side, I've got my 5 divided by 2, so that's just 2.5. On the left hand side, something amazing happens. The r cancels with the r on the bottom. So all you're left with is sine divided by cos, but that's tan. That can be rewritten as tan, so it just becomes tan alpha. So tan alpha is equal to 2.5. And you can now find alpha by inversing tan. Just press inverse tan of 2.5 on your calculator, and you will get an answer for alpha, which is 68.2 degrees. rounded off. And then you can put that alpha back into any one of the first two equations to figure out what r is. But another method, which is just quicker, is you can use Pythagoras on the 5 and the 2. So you can say a squared plus b squared equals c squared, or using the r, you could say r squared would be equal to 5 squared plus 2 squared. So then r would be equal to the square root of that. So that's 25 plus 9, and that's root 29. If you're not sure on that method, then it's easier just to put it into the first equation. You can say r times sine of, now you know alpha is 68.2 is equal to 5, and then type that into your calculator, rearrange for r. Either way, you'll get the same answer, and that's where you can stop on this. Join me for more tomorrow. Assalamu alaikum wa rahmatullahi